So a measure of center is a value at the center or the middle of a data set. And we use measures of center to help describe the characteristics of a data set. So let's look at this data set, which is the time between eruptions for Old Faithful Geyser in Wyoming. And if you look at the frequencies in this frequency distribution, it looks like a majority of the data values are down here between 700 and 730 or so. So we could estimate where the center of this data set might be. And we'd probably say it was somewhere in this area between 710 and 730. Now, if we have a histogram representing our data, then sometimes it's very easy to see where the center of the data set might be. In this histogram, notice that this is approximately bell-shaped. So the center of this histogram is right here in the middle of the graph. So we would estimate that the center of our data would be at about the value 3. Here's another display that we could look at. This is a stem and leaf plot, and this gives us something like a histogram laid on its side. So if we want to look at where the center of this data is, the longest stem that we have here, the stem with the most data values in it, is the 3. So we could estimate that the center of this data would probably be somewhere maybe between the 2 and the 3, because the 2 also has a lot of data values in it. Our first measure of center we're going to talk about is the mean. And this is actually the arithmetic mean, but we usually just call this the mean. And this is the same as the average. So it's what we get if we add all of the values together and then divide by the total number of values. Now I'm going to show you some formulas. For the most part, we're not going to use these formulas because we'll either be using a calculator to calculate these values, or we'll be using some statistical software like StatCrunch. But it's good to know what the symbols in the formulas mean. So here's the first one. This is a Greek capital S, so it's called a sigma. It denotes the sum of a set of values. So that just says to add things up. X is the variable that we usually use to represent the individual data values. N represents the number of data values in a sample or in a data set. And a capital N represents the number of data values in an entire population. So here's one formula for the mean. And this is important, the notation for the mean. One way we can represent the mean is by an X with a bar over it. And this is usually used to mean the mean for a set of sample values. So this comes from a data set that's a sample. So this tells us to add up all the X values and then divide by N, which is the number of values there are. Again, we're just finding the average. Now another form of this formula, this is if we have data from an entire population. So in this case, we usually use a Greek letter. This is called mu. And again, this is telling us to add up all the X values, all the data values, and then we're dividing by capital N because capital N is the number of values in the entire population. So the only difference between these is that this is for a sample, the X bar, and the mu is for a population. Now, a couple of advantages of using the mean as a measure of center. For one thing, it's relatively reliable. Means of samples drawn from the same population don't vary as much as some other measures of center that we could find. Another advantage to the mean is that it takes every data value into account. So every data value is figured into the mean. A disadvantage of using the mean is that because it uses every data value, it's also sensitive to every data value. If we have an extreme value a very large value or a very small value in our data set, it can affect the mean very dramatically. So the mean is not what we call a resistant measure of center. The next measure of center we'll talk about is called the median. And this is just the middle value when the original data values are arranged in order of increasing magnitude. In other words, if they're arranged from smallest to largest, then we look at the positions of those values and we take the value that's in exactly the middle of the list. Sometimes, not very often, we see this written, the median written with an X with a tilde over it. And the median is not significantly affected by extreme values because it only looks at position. It doesn't actually take the values into account. So this would be a resistant measure of center. So let's talk about what resistance actually means. A numerical summary of data is said to be resistant if extreme values, so very large or very small values relative to the data, do not affect its value substantially. Again, the mean is not resistant because extreme values do have a significant effect on its value. The median is resistant because extreme values do not have a significant effect on its value. So let's look at an example of resistance. If we have a list of data values that has 5.4, 1.1, 0.42, 0.73, 0.48, 1.1, and 0.66, the mean of this list is 1.413, and the median is 0.73. Notice that that list does have an extreme value in it. The 5.4 is much, much larger than any of the other values in the list. So we would call that an extreme value. If we exclude that value, so if we leave it out of the list and then we recalculate the mean and the mean changes to 0.748 and the median changes to 0.695. So if we have the 5.4 value in the list, that increases the mean by 0.665, but it only increases the median by 0.035. So it changes the mean a lot more than it changes the median. The median is actually only affected because the addition of another data value changes the position of the median in the list. Now, another measure of center that we can talk about is called the mode. The mode of a variable is the most frequent observation of the variable that occurs in the data set. In other words, it's the value that occurs more times than any other value in the data set. So a set of data can have no mode if there's no value that occurs more than once. It can have one mode if there's one value that occurs more than any other one, or it can even have more than one mode. Maybe there are two different values that both occur the same number of times, and that's the most of any values. Then both of those values would be the mode. So if no observation occurs more than once, then we say the data has no mode. And the mode is the only measure of center that we can use with nominal data. Nominal data is categorical or qualitative data that we can't put into a meaningful order. Here's an example of a place that we could use the mode and we couldn't use the mean or the median. So if we have a frequency distribution for the colors of M&Ms in a bag of plain M&Ms. Here's something that's what we would call nominal data. Our data is the colors of the M&Ms, and those are just words. There's no real order we can put this in that would be very meaningful. So this is nominal data. So to find the mode for this data, we're just looking for the value that occurs more than any other one, and that would be brown. because there were 12 brown M&Ms. That was more than any other color. One more measure of center. And this one isn't used very often, but it does tend to come up in your MyStatLab homework. So I just wanted to mention it so you would know what it is. The mid-range, it's the value halfway between the maximum and the minimum values in the original data set. So if we find the smallest value and the largest value and go halfway between those two, so if we just find the average of those two, that's the mid-range. The mid-range is really sensitive to extremes because it only uses the maximum and minimum values. And this is why we don't very often use this as a measure of center. If we're calculating the mean or the median or the mid-range, one question I get asked a lot is how do I know what to round these off to? So kind of the rule of thumb for rounding off measures of center is that we're going to carry it to one more decimal place than what we have in the original data set. So for example, if our original data set was all integers, then we would round off our mean and our median and our mid-range to one decimal place. If our original data set values went to one decimal place, then we would round our measures of center to 2 decimal places. So we just go one more decimal place than what we have in our data. Okay, so this is a little diagram that talks about what's the best measure of center in different situations. And the top of this gives you some hints about how to calculate these. That would be if you're calculating these by hand, which we're not going to do very often. So the thing I want you to look at in this diagram is the part on the bottom. So for the mean, it reminds you that the mean is sensitive to extreme values, but that sample means tend to vary less than other measures of center. So sample means are nice measures if you have a sample. For the median is often a good choice if there are some extreme values because the median is resistant. For the mode, this is good for data at the nominal level of measurement, like our M&M colors. And the mid-range, we don't use very often. One more thing we're going to talk about, because this does have a little bit to do with measures of center, this is distribution shape. So this would be if we're talking about a distribution for quantitative data. And we already talked about a bell-shaped distribution. So we say a distribution is symmetric if the left half of the histogram is roughly a mirror image of the right half. Now, if it's not symmetric, there are some other things it can be. So it's called skewed if it's not symmetric and extends more to one side than the other. It's skewed to the left if the left tail is longer and the bulk of the data, or most of the data, is on the right side. It's skewed to the right if the right tail is longer and the bulk of the data is on the left side. Now for a bell-shaped distribution, the mean and the median are going to be approximately equal. So if we have a really bell-shaped distribution, then the mean and the median are going to be in approximately the same spot. So here's a pretty well bell-shaped distribution. And this one, the mean and the median are actually exactly the same. Here's another distribution that's approximately bell-shaped. And the mean and the median are pretty close together. The mean is 5.52 and the median is 5.54. Now here's a picture of a skewed distribution. Notice that the highest point is definitely not in the middle of the distribution. Now this one has a longer tail on the right side, so that means that it's skewed to the right. For this one, again, most of our data is not in the middle of the distribution. It's over to the right side. But to figure out whether it's skewed to the right or skewed to the left, you look at where the tail is longer. So this one has a longer tail on the left side. So that means that it's skewed to the left.